Well, grade sixes, we have done it. Let's give ourselves a round of applause. Today marks the last lesson of the year on experimental probability. So, the big thing is theoretical probability and experimental probability are very different. Theoretical probability takes the favorable outcomes and then basically the number of possible outcomes for, picking out marbles. Okay, so you would count how many marbles and then how many green are there. Well, it would be that over that, right? Whereas here, experimental probability, okay, is the likelihood that something occurs based on the results of an experiment. Okay, an experiment. That means quantitative data, numbers, okay, numbered data to find out something. So, Jenny and Morningstar put colored cubes into a bag. They used 4 blue, 2 red, 2 green, and 2 yellow cubes. A cube is picked from the bag at random. The theoretical probability that a blue cube is picked is 4 over 10, okay? So think of it this way. 4 blue, okay, and there's 10. So it'd be 4 over 10, okay? Same with 2, or red, would be 2 over 10, okay? Green would be 2 over 10, and yellow would be 2 over 10 as well. That is theoretical probability, all right? So that's the big difference. Here we go. This is what experimental is. Jenny and Morningstar planned an experiment for the class. Each student would pick a cube from the bag without looking, then replace it. She would do this 10 times. 10 times, okay? So here are the results of one experiment. So they did this 10 times. So the theoretical probability, as stated, was 4 over 10 for blue, okay? 2 over 10 for red. 2 over 10 for green. So that's 4, 6, 8. And 2 over 10 for yellow. All right? So now we're doing an experiment, though. So here, okay, the graphing isn't as effective as it would be for theoretical probability. But here you have the color, okay, the color. We got blue, red, green, and yellow, all right? And what we see here is that for 10 times, we picked 6 blue, 1 red, 1 green, and 2 yellow. So the blue cube was picked 6 times, okay, 6 times. So what that means is, based on there being 4 in that bag, okay, that out of this 10 experiments, 6 times we picked a blue marble, okay? So the experimental probability, as stated before, is the likelihood that something occurs based on the results of an experiment. So here's the big formula. Experimental probability equals number of times an outcome occurs, okay? So that's kind of like your theoretical probability. You have a number of outcomes that occur, okay? Then you have the number of times the experiment is conducted, okay? So what that means is if I do my experiment here instead 25 times, okay, these numbers are all going to change and my bottom number, okay, is going to change as well. So here the experimental probability of picking a blue cube is 6 over 10, or we're not going to work on this too much, but you can simplify it just like ratios and percent. So it's 3 over 5. Okay, this is much different than theoretical. If I said, what is the experimental probability in this experiment of red? It would be 1 over 10. Okay, green would be 1 over 10, and 2 would... Okay, so, as I said before... Okay, so, sorry about that, some technical difficulties. So basically experiment, okay, back to this, all right? So here, okay, my experimental probability of blue is 6 out of 10 because there's 10 experiments done, but I had blue 6 times. 1 out of 10 for the red, 1 out of 10 for the green, and 2 out of 10 for the yellow. So my highest probability in this experiment was the blue, okay? My second was the yellow, and red and green each had only 1. And what we're going to see, though, is there is a huge difference between theoretical and experimental. However, look at the theoretical probability of these two. Okay, we had 4 over 10 over here, 2 over 10, 2 over 10, and 2 over 10. So as we can see, this one was the most likely to get the marble picked because they had the most. So that can sometimes correlate with the experimental and theoretical probability. So Janney and Morningstar combined the results from 10 experiments. So they did 10 different experiments. So they did one, they sat down, and they wrote all the blue, red, green, yellow marbles picked, okay? Then they did it again, then they did it again, then they did it again, until they did 100 trials, all right? So what you're going to see is you have the color here, red, green, and yellow. And then the experiment, we chose 43 blue ones out of 100 trials. So it's 43 out of 100, okay? So the blue cube was picked 43 times, so the experimental probability was 43 over 100. So here, guys, okay, what we can say, though, is that the experimental probability is close to the theoretical probability. If you remember, the theoretical probability was 4 over 10, okay? So what we see here is 4 over 10 is actually, if we multiply this by 10 and this by 10, we're going to get 40 over 100. 40 over 100 is really close to 43 over 100. So sometimes these trials that we conduct, the closer the experimental probability may come to the theoretical. Now, that's not always going to be the case, though, okay? It's an experiment, so that's why it can be so different, But look at this, too. We had red with 22 out of 100, okay, and my theoretical probability was 2 out of 10. Well, 2 out of 10 is 20 over 100. So 22 over 100 and 20 over 100, this is my theoretical and this is my, this is my experimental and this is my theoretical. Those are both pretty much the same, right? So what they're saying here is when you do more experiments, the closer it's going to be to the theoretical probability. And that is something that you should highlight in your notes, okay? So going back to this slide, this is what you need to know. Experimental probability is the number of times an outcome occurs, okay? And then the number of times the experiment is conducted. So let's say we have a dice, okay? We have a dice, all right? And I rolled it 10 times, okay? So 10 times is my bottom number with the experiment, okay? And now let's say I rolled 2 times, okay? So this is number of dice. And then experiment here, okay? So we have 3, we rolled twice, we'll go 4, we rolled 3 times, we'll go 5, we rolled 2 times, and 6, we rolled 3 times, and then 2, 0, and 1, 0, okay? Well, if I said find the theoretical probability, okay, it would be 1 over 6, because we have 1 number, and then we have 6 possible outcomes. But because we conducted this experiment 10 times, okay, my experimental probability for 3 would be 2 out of 10. My experimental probability for 4 would be 3 out of 10. My experimental probability for 5 would have been 2 out of 10. And finally, for 6, it would have been 3 out of 10. So based on what you conduct in your survey is the data that you're going to use for this.